So before we were mostly theorists, but now we will have 2 labs. This is one of them, and Kirill Korlikov is got part of the big, I forget what it's called.
Right, coming.
Yeah, but the name of the grant was I've forgotten the name of the AEP.
The AOE grant.
AOE,
yes,
he got a part of a big AOE grant, and to build next generation detectors for Atlas. And so that's related to what we do. So this is our outstanding graduate student.
I love it.
A local outstanding graduate student, Albert. But this is the quantum optics for Astrophysics and Cosmology lab. And we're doing that at multiple levels. Namely, we're detecting individual quanta, mostly photons, optical photons, but various kinds of photons. But we're also using quantum devices to do it, and we're trying to move forward and honor the mathematician here. One of the things that we're going to be moving forward on is quantum statistics, that is photon statistics. And if you had ever paid attention to that, lasers have Poisson statistics, even though it's constant average power of the noise. And thermal noise has a broader than Poisson statistics. And classically, there can't be narrower than Poisson, but in quantum processes there can be. And in fact, one of the projects that Albert did early, quantum dots are a thing. You prove you have a quantum dot when you prove it has Poisson statistics. So resonance scattering, things like that have this, where the spacing of the photons much more uniform than you would expect from Poisson when it's random. So there is a set of things we're doing. We're trying to build the tools to see individual photons, but also build tools to do them at extremely high speeds where we can actually do statistical counting and measuring and so forth. But there's a whole series of things we're doing, and one of those is to look for lasers in space and lasers in cosmology, which are things that are seen and predicted. And we want to do that, but they're relevant to condensed matter physics and other things too, including even quantum computing. And the problem is we have to be clean and we have to be careful, and we have to have a lot of skill. And so this lab, we're going to be trying to build these devices that are very fast, and also devices that look at individual quanta with very high precision and care. And we have a room in here for students. Hopefully we will be training a whole new set of generation of students. So we have a couple, I don't see Sean, but we have a couple here that work in the lab, Bing and Albert and Sean, who's doing it, and trying to recruit more. But it turns out not so many people apply to graduate school in experimental physics. So,
well, we have a list now.
Yeah, I looked through the list.
Okay.
There were only 8 people interested in astrophysics and cosmology and handy physics, and so I looked through all those carefully. They both want to be theorists, but we have to advertise that we're experiment. But we wanted to celebrate that we're making this transition, and that we actually have starting students. But we have a lab which is finally refurbished and at a level we think we can do it. And now we got to fill it up with equipment, and then with great experiments and great students and postdocs. So I want to thank everybody for getting into this state, and I want to especially thank Albert for getting a lot of this organized. But we have a lot of people, TK and Wolf especially, who I can't see that, who helped a lot, and we have somewhere the gentleman that helped furbish the lab, and they did a great job. And we could sneak. They were doing the final stuff, but I could sneak in because when they were in there working, they left the door unlocked. Normally, we weren't allowed to come in here, but we could see what was happening. So, anyway, thank you all very much. Okay, I have much more to say, but I think it's more important that people realize we're passing this milestone. The next milestone will be when we have equipment in here and we are doing some great experiments. And so, go ahead and partake.